This is a SUTOTAL production. Hello, surveyors. I am SUTOTAL, and this is going to be our first practice video related to math practice. So before we actually get in the textbook, in this first video, we're going to look at pretty much doing algebra, rearranging equations to solve for certain things. So with this, I'm doing it in terms of solving for variables. So here we go in our first one here. It says solve for 9x minus 12 is equal to 14x plus 42. Alright, and so it doesn't really matter which side you start on. I just work left to right. And so big thing here is when I have multiplication and then addition, subtraction, or division, addition, subtraction, it's always best if you kind of do the addition, subtraction first. So in this case, I'm going to add 12 to both sides. Alright, and so that's going to cancel out the 12 there. So then that's going to give me 9x is equal to 14x plus 42 plus 12, that should be 54. Alright, and so now what I can do is I got all the integers on one side. Now I can put all the variables on the other. And so now I would just subtract both sides by 14x. So that would cancel. So 9 minus 14 should be negative 5x is going to equal to 54. So now what do I have? I've just got an integer. Excuse me. I have an integer, and then I have my variable being multiplied by a number. So now I would just divide both sides by negative 5. And so that means the negative 5 here would cancel. So if I come up here to solve for it, I would get x is equal to negative 54 over 5. Now you could do it that way, or especially when we work in Canvas, we're going to see a lot of times it's not easy to put in fractions. So what we're going to do is go ahead and do this division. So I would say negative 54 divided by 5, what does that equal? Negative 10.8. So technically all of that is correct, right? So either the negative 54 over 5 or the negative 10.8. Alright, next up, if we look, we got 82 is equal to 9/4 t plus 7. So I see like multiplication, division with my variable, an integer and an integer. So I'm going to subtract both sides by 7 first. So 82 minus 7 would be 75. That would give me 9 over 4 times t. So now based off this, I see 9/4 is multiplied by t. Or you could think of it like it's 9 times t, then divided by 4. So what I'm going to do, this is divided by 4 here, right? So I'm just going to multiply both sides by 4. Alright, and so let me kind of come up here because I'm running out of room. So 4 times 75, that should give me 300. So that becomes 300. These 4's now cancel because divide by 4, multiply by 4. And so now I get that's equal to 9t. So now 9 multiplying into t means I just divide on both sides by 9. And so I could think of this as either 300 divided by 9 is equal to t, or I could do that division, right? And so let's get ourselves a decimal point. 300 divided by 9, that would be 33.33333. So what I'm going to do is I'm just going to stop it at 2 decimal points. All right, so I'm not just going to keep writing 3's. So that's where I'm going to stop at 2 decimal points. All right, next up, what do we got here? Ooh, we've got some fancy stuff. So we've got 7/8z plus 7 is equal to 8/9z minus 8. So I've got some multiplication, division. I've got some addition, subtraction. So for number 3 here, I'm going to go ahead and just not divide. I'm going to subtract both sides by 7. So that'll cancel. So that'll give me 7/8 z is going to be equal to 8/9 z minus 15. Alright, and so now I can think of these as 2 fractions in front of the z. So what I can actually do is I can subtract both sides by 8/9 z, subtract 8/9 z. And so to kind of clear that up, what that would look like, I'd really be looking at 7/8 minus 8/9. So I'm going to do that subtraction, and then that will multiply into z, and then give me negative 15. All right, so I'm going to be pretty easy here. The common denominator, 8 and 9, I'm just going to say 8 times 9 is the common denominator. So that means I'm really going to have to turn this into like whatever 8 times 9 is, 72, and whatever 9 times 8 is, 72. So what I'm really looking at is something over 72 minus something over 72 times z is going to be equal to negative 15. All right, so from there, so to get what the 7 turns into, right, it's 7 times 9. So what does that give me? Oopsie, I keep knocking the paper around. 7 times 9 is 63. 8 times 8 is 64. That's an easy one. All right, so what do I get? 63 minus 64. That's 1. Negative 1 over 72. So then this becomes negative 1 over 72z is going to be equal to negative 15. So it's really just like saying z divided by negative 72 here. So I can multiply both sides by negative 72. All right, and so that would cancel. So I would get z by itself is equal to negative 15 times negative 72, and that comes out to 1,080. All right, so that would be my answer. All right, next up, on our fourth one here, we've got 2r plus 15 is equal to 13r minus 9. So I'm going to subtract 15 from both sides. So minus 15 minus 15. So that'll go away. So I'll get 2r is equal to 13r minus, so 9 and 15 would be 24. Minus 24. All right, and then I'm going to see now I need to get the r's on the same side. So I'm going to subtract 13r minus 13r. So does it give me? Negative 11r is equal to negative 24. All right, so let's bring that up here. So negative 11r is equal to negative 24. So I have negative 11 times r. So I need to divide by negative 11, divide by negative 11. So that would become r is equal to, it's negative over negative, so it would be 24 over 11. And don't want to stop at a fraction, so what is 24 divided by 11? 24 divided by 11 equals 2.182. All right, so 2.182. I'm being kind of arbitrary here in where I'm stopping with decimal points, but if you ever had to know, what decimal point to stop at, the question will tell you. Okay. All right, next up. Okay, this one actually has a typo in it, so it missed something, so there should actually be a +2 right there. Okay, so yours will be corrected, but mine I hadn't corrected yet, so I pulled an old paper, a wrong paper. So I need to have that +2 in there. All right, so what I see is I don't have addition subtraction on either side. I have this multiplication on both sides. So what's probably going to work better in my favor is if I think about this as being divided by 2. So, and this divided by 5. So what I'm going to do is I'm going to multiply this side by 5, so those will cancel. But then I'm also going to have to multiply this whole side by 5. So that gives me 4y, right? Now, what does that become? What's 5 times y over 2? It's 5y over 2, right? But then I also have to do the 5 times the 2 as well, so then that gets me 5 times 2 is 10, so plus 10. Now, what I can do is I have this y variable and this y variable. So I can go ahead and subtract 5y over 2 from both sides. Right? And so what is that going to look like? That's going to give me 4 minus 5 over 2 times y, right, is going to be equal to 10. All right, now to do this, I need to convert that to a fraction. This one's a little easier. So 4 is the same thing as saying 8 over 2. So you're looking at 8 over 2 minus 5 over 2. So you're really just subtracting the 8 and the 5. So 8 minus 5 is 3. So you get 3 over 2 y is equal to 10. Now, in order to get rid of that fraction, right, we could just say, all right, I'll multiply both sides by 2. All right, so what does that give me? That gives me 3y is equal to 20. And then if I come up here, let me rewrite it. 3y is equal to to 20. All right, now with 3y being equal to 20, now I just divide both sides by 3. So I get y is equal to 20 over 3. And then if you do that division, 20 divided by 3, you get 6.67. All right, so technically the fraction's more precise in that you get all those decimal points, but I did have to round it because you get 6.6 repeating. And so I just did it to do 2 decimal points here, 6.67. All right, now that's using numbers with like the regular algebraic variables you're used to seeing. But what do you do when you're actually given an equation here? So here, right, here we have the ideal gas law. We'll learn all about this later, but one thing, the same algebra we just did, we can do if we don't have any actual numbers. So for instance, it says here, rearrange PV equals nRT, and in doing so, solve for P. So you notice I don't have P isolated on either side. P stands for pressure. So I don't have pressure isolated on either side. So that means if I'm looking at PV equals nRT, I need to get P by itself, which means I need to remove V from this side. And these two are understood to be multiplying by one another. So I would just divide V here, but what I do to one side I have to do to the other, so divide by V there. So those would cancel, and then that would become P is equal to nRT over V. So that would be us solving for P by rearranging the equation. We can do the same thing in solving for T here. So we got PV is equal to nRT. All right, so I need to get T by itself, which means I need to get rid of this N and this R. So all of this is multiplication on this side. So I can say divide by NR on that side and then do it to the other side. So divide by NR. So here the NR's cancel. And then what do I get? I get PV over NR is equal to T. All right, so that would be us solving for T. Awesome. All right, another one we have, this is a thermochemistry equation. We won't necessarily see it, but either way, it's still good practice. So here we have a combination. Now it's not just multiplication. We have multiplication, and we also have subtraction. So in this one's a little easier because it just says solve for C. So C is here by itself. So when we look at Q is equal to MC, and then our TF minus TI, right, you just need to get that by itself. So C is being multiplied by M, but it's also being multiplied by all of this in parentheses. So we can just divide both sides by the M, which is also being multiplied by the TF minus TI in parentheses. So do that to both sides, TF minus TI. All right, and so here the M cancels, here the TF TI cancels, so that means I do get C by itself. So cleaning it up, making it look better, I get Q over M times TF minus TI is equal to C. All right, and so that's what I get. All right, so that would be solving for C. Now, this second one here wants me to solve for TI, and that's going to be a little more complicated because it's in this subtraction parentheses stuff here. So what do we want to do first? Well, we want to get the TF minus TI by itself first. So let's look at Q equal MC TF minus TI. So what do I mean by get this stuff in parentheses by itself? I want this first isolated on one side by itself, get rid of the MC. So let's first divide both sides by MC, right? So there they'd cancel. So what would I get? This would turn into Q over MC is equal to TF minus TI. Now I've got them by themselves, and so I can ignore the parentheses because they're by themselves over here. So now from here, it's very simple. All I got to do to get TI by itself, right, because I got to get that by itself. So TF minus TI, I would have to subtract TF from both sides. Right, and what would that look like? That would give me Q over MC, right, I'm going to put that in parentheses, minus TF is going to be equal to negative TI, right? Now, with this is a negative TI. So what I can do is I can just multiply both sides by negative 1, so this entire side by negative 1, and then what does this turn into? Right, it turns into negative QMC plus TF is equal to TI. So that would be it now that it's no longer a negative. Okay. All right. Okay, cool. Next. All right, so when we look up here, we have to solve for EA. So in looking at what we have here, we've got this E variable. So if you recall, E and natural log, those are inverses of one another. They're opposites. So to get rid of this E, we're actually going to need to take the natural log of both sides. So I'm going to start by writing this equation as natural log of K, because I'm taking the natural log of both sides, is going to be equal to the natural log of A, and then our E operator up to the negative EA over RT, like so. Now, when I take the natural log of all of this right here, right, this is A times E to this power. So this multiplication between these two, so there's multiplication there, we can actually separate this. So that means I can get natural log of K is going to be equal to natural log of A, and then because these two are multiplied, I can say plus the natural log of E to the negative EA over RT. Okay? Now, in this case, natural log and E are opposites. They cancel each other out. So this turns into, let me come up here, this turns into natural log of K is going to be equal to the natural log of A plus negative EA over RT, like so. All right, now we have to, what are we solving for? EA. Okay, so what do we have? We've got addition between these two, so I can subtract natural log of A from both sides to give me natural log of K minus natural log of A, and now it's gone from this side, equal to negative EA over RT. All right, and so I need to get EA by itself, so I can get rid of this division by multiplying both sides by negative RT. Negative RT. All right, that's what I'm doing up there, I'm multiplying. All right, so what does that give me? That gives me negative RT times natural log of K minus natural log of A, all in parentheses, is going to be equal to EA. All right? Okay, next one. Issue here when we solve for T with this. Now, if you recall, right, I said when we take this, we can take the natural log of both sides to get this. So I'm actually going to start from right here, from this line, when we solve for T. So if you remember, we had natural log of K is equal to, let me put a little line here so we can tell. All right, so natural log of K is going to be equal to natural log of A plus negative EA over RT. All right, now here's the deal. We're going to subtract, because we need the T now. So what are we going to do? I'm going to do something a little similar here. We're going to have to take the, we're going to subtract natural log of A from both sides. So we'll get the natural log of K minus natural log of A is equal to negative EA over RT. Now, T here is in the denominator. I need it up top. So what I'm going to do is I'm going to multiply both sides by RT, like very similar to what we did before. Y'all, I totally screwed up there. That's supposed to be times. So it's supposed to multiply by negative RT. I can't believe I did that, y'all. Times negative RT. That's it. Negative RT. Alright, so I'm going to multiply both sides by the RT here. And that cancels on this side. So what do I get? I get R times T. And all of that is times the natural log of K minus natural log of A. And all of that equals negative EA. Alright, now I need to do a few things. So I need to get the T by itself. So what can I do? I can divide both sides by R times natural log of K minus natural log of EA. Do that to both sides. R natural log of K minus natural log of A. Like so. And so to clean that up, right, R goes away, and then that natural log subtraction goes away on this side. So what do I get? I get T is equal to negative EA over r natural log of k minus natural log of a. All right, so that is solving for t. All right, so this will conclude our video for the practice.